All of you. Welcome to webinar class. Today's class continue electric charges and fields. Today topic is quantized of charge. This is very important in IP public examination in Telangana. 2 marks question is given that. So what is the quantized of charge? So first point, experimentally it is established that all three multiples of a basic unit of charge denoted by n. N is a where n is any integer or positive or negative charge. So finally, the charge Q on a body is always given by Q is equal to plus or minus Ne. So once again, quantized of a charge experimentally it is sorry for the disturbance. Experimentally, it is established that all three multiples of basic units of charge denoted small n. So where n is any integer, positive or negative. Next point, the charge Q on a body is always given by Q is equal to Ne or Q is equal to plus or minus Ne. This basic unit of charge is the charge that an electron or photon carriers. So because of Q is equal to plus or minus Ne. So where small e are electron or proton. So that means both the charges like positive or negative. So finally you can write Q is equal to plus or minus Ne. This is the next one. By convention, the charge on electron is taken be negative. So for example, already discussed about conduction, convection and insulation. So where by convention, you take the convention, the charge on electron is taken to be negative. Next point, finally, therefore, charge on an electron is written as a negative E and that on proton as a plus E. And that means already you know that electron are negative charge terminal and also proton are positive terminal. So you can write finally the charge on electron is written as negative, that means negative E, and that on a proton. So proton as taken as plus E. This is the quantized of charge. So simply you can write Q is equal to plus or minus Ne, where Q is equal to charge N, where N is an integer or positive or negative. Where small e, you can write you take the electron negative terminal and proton positive terminal. So next one, the continuation next point, the fact that electric charge is always an integral multiple of E is termed as a quantization of a charge. So this is a very important point. The fact that electric charge, so electric charge means positive or negative, is always an integral multiply because of n is a nothing but an integer. So you can write the number of terms like a q1, q2, q3, so on, qn. And E is a terminated as quantized of charge. Next point, there are a large number of situations in physics where certain physical quantities are quantized. So what is the next point? There are a large number of situations in physics. There are a large number of situations in a physics where certain physical quantities are quantized. So already you know that physical quantities like distance, mass, temperature, there are fundamental physical quantities and there are physical quantities. So many is there in first year units and measurements lesson. So already you know that. Next, the same condition you can apply where physics where certain physical quantities are quantized. Next point, the quantization of a charge, as first suggested by the experimentally laws of electrostatics discovered by English experiment in Faraday. So already you know that scientist name Faraday. The first discussion about the charge. The quantization of charge was first suggested by the experimentally. So the experimentally proved that quantization of a charge, who is the discoverer or who is the experimentally proved that that scientist name is Faraday. Next point, it was experimentally denoted by Milcon. So after the Faraday experiment, some errors are there, so some limitations are there. So again, this experiment continue the another scientist, another scientist, Milcon, the year of 1912. The finally in the international system, already you know that international system is like a SI, some system of international of units. A unit of charge is called a coulomb and is denoted by the symbol C. Already yesterday class discussed about the uh, charge units are coulombs. So this is the SI method. So already you know that what is the SI method? That is a system of international. So the system of international, the units of charge is called coulombs. The generally the indicated by coulombs capital C. This is the quantization of a charge. Next one. So already you know that another scientist, a coulomb. A coulomb is denoted as the unit of terms of electric charge. So the, this is a very important one, 4 marks question in our Board of Intermediate in Telangana. So Coulomb's inverse square law. So the related to Coulomb's law, Coulomb's inverse square law statement. The force of attraction or repulsion. The force of attraction or repulsion between two stationary electric charges is directly proportional to the product of magnitude of the two charges and is inversely proportional to the square of the distance between them. And this force acts along the line joining those two charges. This is the statement, very important 4 marks question. Once again, Coulomb's inverse square law statement. The force of attraction or repulsion. That means you can observe the force. There are already discussed about previous class. The force of attraction or force of repulsion. Whatever you are using, these force between two stationary electric charges. Stationary electric charges mean nothing but electrostatics at rest. So stationary electric charges is directly proportional to the product of magnitude, the product of magnitude of the two charges and is inversely proportional to the square of distance between them. And this force acts along the line joining those two charges. For example, the experimentally prove that let us consider 2 point charges Q1 and Q2 at rest at a points like Q Q1 is A position and Q2 is B position. So let us consider 2 point charges Q1 and Q2 at rest at points capital A and capital B. These two charges separation between small distance like a small r. So the separation between those two charges is small r. That means the distance between two charges Q1 and Q2 are separated by a distance small r. So what is the statement? The force between two charges. So I am consider force capital F. So finally F is directly proportional to Q1 and Q2 and F is inversely proportional to 1 by r square. So where Q1 Q2 charges r distance. F is directly proportional to Q1 and Q2. One equation. This is equation number 1. Second equation, F is direct inversely proportional to square of the distance. That is F is inversely proportional to 1 by r square. Finally, equation capital F directly proportional to Q1 Q2 by r square. So proportional where I am consider proportional constant k. So that means capital F is equal to 1 by 4 pi epsilon Q1 Q2 by r square. So k is a proportional constant. The Coulomb's take constant value k is equal to 1 by 4 pi epsilon. So already you know that 4 is the constant. Epsilon means permittivity of a medium, and pi is also constant. Already you know that value 3.14. So the scientists both the force and the product of the charges and square of the distance both are equal, which constant is taken as 1 by 4 pi epsilon. So already you know that 4 is the constant, pi also constant, that value is 3.14. Epsilon means permittivity of a medium. Sometimes you can observe that in any free space. So free space that is using of epsilon naught. The epsilon naught means permittivity of a free space. So this value epsilon naught is equal to 8.8542 into 10 to the 4 of minus 12. Once again, I repeat the constant value epsilon naught is equal to 8.8542 into 10 to the 4 of minus 12 Coulomb square by Newton meter square. This is the unit. Coulomb square by Newton meter square, where constant value k is equal to 9 into 10 to the 4 of 9. Constant value k is equal to 9 into 10 to the 4 of 9 units Newton meter square per Coulomb square. Newton meter square per Coulomb square. This is the Coulomb's inverse square law. This is very important. So you can observe the second point in terms of this definition, 1 coulomb, you write it is a 1 ampere. And that means charge is equal to current. So already you know that the charge units coulombs and current units amperes. So this is a universal constant. So for example, already discussed about yesterday class, E means charge. That constant value 1.602 into 10 to the power of minus 19 coulombs. So already just now, what is the quantized equation? Q is equal to Ne. So where you can observe that n is a integer. So what is the value of n? So n is equal to q by e. So thus there are about 6 into 10 to the power of 18 electrons in a charge of 1 coulomb. This is the most important. So there are about 6 into 10 to the power of 18 electrons in a charge of 1 coulomb. So finally, n is equal formula q by e, that is equal to 1 by 1.602 into 10 to the power of minus 19. This equation simplify finally, that is value is equal to 6 into 10 to the power of 18. This is the most important in IP level 2 marks question. So next point, in electrostatic charges of this large magnitude are 1 microcoulombs. That means already you know that 1 microcoulomb is equal to 10 to the power of minus 6 or 1 millicoulombs. That value is equal to 10 to the power of minus 3. And that means the above equation you can identify or observe both the values like a microcoulombs and millicoulombs. So micro symbol are mu. 1 mu c is equal to 10 to the power of minus 6 coulombs. And millicoulombs. The millicoulombs are indicated by 1 mc. M in millicoulombs. So finally, limitations of Coulomb's law. So Coulomb's scientists also some of the limitations are there. This is the very important in competitive exams, MCET and NEET level, asking what is the limitations of Coulomb's law. So first one, it is valid for only point charges. What is the first limitation? This is very important. It is valid for only point charges. And that means the Coulomb only discusses about the electrostatics. That means at rest charges. If the charges are motion or charges are moving, it's like a current electricity, does not explain the motion of electrons or motion of moving of electrons. It is only told at rest charges. This is the limitation. Once again, it is valid for only point charges. So this is the first point. And the second one, it is valid for static charges. It is valid for only static charges. That means does not applicable in dynamic charges. This is the limitations of Coulomb. This is very important 4 marks question in Board of Intermediate. The next topic, so next point, if the protons and electrons are the only basic charges in the inverse. So what is the next point? If the protons and electrons, protons mean positive terminals and electrons mean negative terminals, are the only basic charges in the inverse. All the observable charges have to be integral multiples of E. So the charge is quantized. Already just now I said that Q is equal to plus or minus Ne. Why? Because I am consider plus or minus. So that means E is a charge or positive and negative. So where N is a integer. So once again I repeat this point. If the protons and electrons are the only basic charges in the inverse, all the observable charges have to be integral multiple of E. So next point. Thus, if a body contains N1 electrons and N2 protons, the total amount of charge on the body is. So already yesterday class discussed about the sum of the charges is equal to individual charges. Q is equal Q1 plus Q2 plus Q3 plus so on. So you can observe that this condition. If a body contains how many electrons are there? N1 electrons. How many protons are there? N2 protons. Finally, the total amount of charge on the body is N2 into E. Why? Because plus E, that means proton is a positive terminal. So you can write N2 into E plus N1 into minus E. So that means minus E means electrons. So negative terminal. So you can observe that that is equal to N2 minus N1 into E. So where E is the common. So N2 is a positive terminal and N1 is a negative. So because that is equal to N2 minus N1 into small e. Since already you know that N1 and N2 are integers, their difference is always an integer. So where N1 and N2 are integer, automatically the difference between the integers also integer. Next point. The charge on any body is always an integral multiple of E and can be increased also in steps of E. And that means, for example, you can observe any body is always an integral multiple of E and can be increased also in steps of E. This is the most important point. So body is always integral multiplier increasing in a steps of charge. So finally, next point, the step size E is however very small because at the microscopic level we deal with charge of few microcoulombs. So this is observe very small bodies also. Why? Because micro 10 to the power of minus 6. So this is a very less value. You can observe this size also using of microscopic level. So next one. So you can observe the microscope. So next point. At this scale of fact, that charge of a body can integrally multiply in units of E is not visible. So why? Because not visible. This is a very small value. So in microscope does not visible this value. The next point, this is generally the nature of a continuous. So you can observe this one. This is a very important point. This situation can be compared with the geometrical concepts of points and lines. This is a very important. Already you can observe microscope or telescope are nothing but some milli micro and milli values are there. So same you can observe this point. This situation can be compared with the geometrical concepts of points and lines. So you can observe the points and lines of a microscope scale. The next point, capital A donated line viewed from a distance of the another point as but is not continuous in reality. So why? Because in this case you can observe that it is only stationary points, so does not moving. So because of it is not really prove that. So finally, as many points very close to each other, normally given as impressions of a continuous line, many small charges taken together appears as a continuous charge distribution. This is very important one. Once again, I can repeat. As many points, you can observe the different positions A, B, C, like some different points very close to each other. So, for example, both the you can observe the 3 or 4 points, and these points are very close to each other. That means very small distance. Normally given on impressions of a continuous line. So that means nothing but a axial line or straight line. You can observe the all charges very small distance and nearest to each charges, and also one a straight line. Many small charges taken together appears is nothing but a together very nearest. The continuous charge is distribution. So when this is where is possible this one, that means the charge are very nearest to another charges. So the charge are distribution. So this is a very important point. So next one. So observe that one at the microscopic level where the charges invalued are of the order of a few tens or hundreds of E. So this is a very important. So charge, that means at the microscopic level where the charges invalued were of the order of a few tens of hundreds of electrons or hundreds of protons. That means the generally the microscopic level is equal 10 terms or 100 terms. So already just now discussed E is equal to 1.6 into 24 of minus 19 coulombs. So this value some things like 10 to the 4 of minus times of the microscopic level. So the next point, at this scale, the fact that charge can increase or decrease. Both the conditions are increase or decrease only in units of small e is not very different from saying that charge can take an continuous values. So once again I can repeat this point at this scale. So the fact that charge can charge can increase or decrease only in units of E. That means depending on only charge. You mean charge is not very different from saying that charge can take an continuous value. This is the very important point. That means charge can increase or decreasing only units of E, but is not very different from saying that charge can take an continuous values. This is a very important point. You can observe the different of two conditions. And next point, thus at the microscopic level, the quantization of a charge has no partial consumption can be ignored. This is the finally the microscopic level the charge is quantized only partially. This is the quantized of charge points. The next one, that is they can be counted, they occurs in discrete lamps, and quantization of a charge cannot be ignored. And that means you can observe the take the microscope values very list values are there. So you can observe the uh, one nothing but in scale experimentally. You can observe telescope like the second year practical one of the experiment like a expansion of a solid. You can observe the using of tele microscoping. So experimental you can observe the microscopic level scale and this one. So finally it is the scale invaluated that is very important. So finally what is you can observe that the scale invalued that is very important. So the next one. So next topic, you can observe that conservation of charge. What is the next point? What is the next topic? Subtopic, conservation of charge. So already in first year chapters work, energy and power, you can observe conservation force and non-conservation force. You can already some idea is there. So gravitational force, frictional force, conservation is a best example of gravitational force, and non-conservative mean viscous force or frictional force. So law of conservation of charge. We already observed that law of conservation of momentum. So just I can uh, repeat first here like a law of conservation of energy. That means before momentum is equal to after momentum. That is the first year law of conservation of force. So in this case, you can observe conservation of charge. Law of conservation of charge. The law of conservation of electric charge states that for an isolated system, the net electric charge always remains constant. This is the law of conservation of energy. Once again, I can repeat the law of conservation of electric charge states that for an isolated system, the net electric charge always remains constant. So you can observe this diagram. Let us consider 2 point charges like A and B. So A positive charge, B also positive charge. After contact, A also positive charge, B also positive charge. So what is you can observe that the charges are transferred from object B to object A, but the total charge is always constant for the system. So this is a very important. And that means only the charge are transformed from object B to object A, but the total charge always remains constant or always constant for the system. That means system does not the loss of charge, but only charge are transfer object B to object A. This is the law of conservation of charge. So law of conservation of energy or law of conservation of uh, charge, both are equal, but only one is the change. Where you can observe the law of conservation of charge, so you can observe the charge. The law of conservation of energy, you can observe the momentum. That is a difference. So all of you understood. So I can the next topic. So one of the example of law of conservation of energy, law of conservation of charge. A glass rod when rubbed with a skill becomes a positive as it loses electrons, and the skill becomes a negative by an equal amount of gaining these electrons. So simply you can observe, so that means the positive charge or negative charge you can observe. So the equal amount of these electrons are the isolated of the glass rod and silk is neutral. So one of the best example already you can observe the first introduction class electric charges. So the first Greek scientist also observed this type of application. So once again you can observe glass rod and rubbed with a silk becomes a positive. It is loss of electrons and the silk becomes a negative by an
Sir,
equal amount of gaining these
close the
electrons.
session, sir.
Okay, okay.
Ah,
So finally, this isolated system of glass rod and silk is neutral. So this is the today the charge of quantized and Coulomb's law. This is the most important. So tomorrow I will continue the force between multiple charges and electric field of intensity and properties of electric lines of force. So thank you all of you. Today assignment the law of the explain the Coulomb's inverse square law and also what is the charge quantization. So thank you everyone.